Hello, ladies and gentlemen. We are taking another look at volcanoes today, and we're going to actually take a look at different types of volcanoes and their what kinds of eruptions they have. Last week you looked at an interactive website that talked about 4 different kinds of reaction or volcanoes, excuse me, and we're going to go ahead today and talk about kind of narrow that down to 3 of them. We're going to leave lava domes out for now. We're actually going to start here with, well, if I can get... All right, we got it going here. We're going to start here with cinder cones. We're going to talk a little bit about what each of these volcanoes kind of looks like, what some of its characteristics are, but you're going to notice I have some information highlighted about what their eruptions are like, because in your lab today, you're going to be doing or observing or watching some different chemical reactions, and I'm going to ask you to compare that reaction with what you learn here about the types of eruptions and decide which kind of volcano you think that reaction is most like and why you think so. So cinder cones are smaller than the other 2 types of volcanoes that we're going to look at, significantly smaller. And they form when lava is actually thrown up from the vent and kind of breaks up before hitting the ground into these like cinders and ash and pieces of debris. This accumulates and gathers and forms the actual cone shape of the cinder cone. So an eruption with a cinder cone tends to throw up pieces of stuff, ash and small rocks and things like that. Now we're not really going to see any of that specifically in the lab today, but you can always look to see if you see a reaction where things are thrown directly up. Okay. So that would be perhaps more of a cinder cone type of eruption. You may or may not see that. All right, let's go to our next slide. This is just a picture of a cinder cone found in New Mexico. It's kind of looking down on it from above. Now we're going to take a look at shield volcanoes. Shield volcanoes have really broad bases and the slopes are not steep. They're very gently sloping. These shield volcanoes are much, much larger than the cinder cones we just looked at. Because the base is so wide, the volcano can be very tall, and sometimes it's deceptively tall. It doesn't look that tall because it's not steep, but it can actually be quite tall. The lava in a shield volcano tends to kind of flow, and it kind of builds up over time to form the volcano, and the lava in a shield volcano is not very viscous. In other words, it's thin and runny, maybe almost like water, probably a little thicker than that. But it's not super thick and slow moving. It's actually quite runny. It can flow quite quickly, and it flows very easily, and that's why the shield volcano has these gently sloping sides, because the lava can flow for quite a long distance before it kind of stops and starts to build up. So we have these very wide shield volcanoes because of the thin, runny, easily flowing lava. So watch for that in any of the demonstrations today. Maybe there'll be one, maybe there'll be more than one, but watch for that in your lab today. Here is an example of a shield volcano. This is Mauna Loa in Hawaii. All right, the last one we're going to look at today is the composite volcano. These develop when layers of materials from explosive eruptions, so composite volcanoes have very explosive eruptions. The shield are not terribly explosive. They are just more kind of easy flowing. The cinder cones are kind of explosive because the material shoots straight up in the air. So you have a couple here that are kind of explosive. Both the cinder cone and the composite, the ones that begin with a C. I'm not sure that makes a difference, but I just observed that myself. The materials include both lava and pyroclastic materials, which are various sizes of rocks and other debris that can shoot into the air. Again, we probably won't have anything that represents any pyroclastic or debris or rocks. We're looking more for lava flow types in your lab today. These composite volcanoes erupt after the material kind of builds up for a while. It kind of bulges under the surface, and then it pops almost like a pimple. The lava in a composite volcano is very thick and kind of flows up out of the top of the volcano and then down over the edges. So it doesn't necessarily shoot way up into the air, even though it's kind of explosive. It might shoot a little bit. But the lava part of it, the pyroclastic materials and ash and rocks and things tend to go up into the air. But the lava itself, because it's so thick, it tends to just kind of ooze out and flow down over the sides. All right, so watch for something that you think might represent that in your lab today. An example of a composite volcano would be Mount Shasta in California. All right, ladies and gentlemen, enjoy your lab, and I will talk to you later.